Hello everyone, in this video I'll be explaining metals and non-metals of class 10 science, that is our chapter 3. Now in this chapter of metals and non-metals we will be studying the physical and the chemical properties of metals and non-metals. Now on the basis of their physical and chemical properties, all the elements are divided into three groups. That is, we have our metals, non-metals, and then metalloids. So in our class 10 syllabus we will be studying the physical and the chemical properties of metals and then non-metals. Now let us first define what is a metal and then a non-metal. Now a metal is an element that is malleable, ductile, and conducts electricity. For example, we have copper, iron, aluminium, gold, silver, we have chromium, sodium, magnesium, nickel, cobalt, etc. Now all of these are metals and they are malleable, ductile, and conducts electricity. Now remember, all metals are solids except we have all the metals are solid except for one metal that is known as our mercury. Mercury is the only metal that is a liquid. Mercury is the only metal that is a liquid. So that is known as our metals, which is malleable, ductile, and conducts electricity. Now how do we define a non-metal? A non-metal is an element that is neither ductile nor malleable and does not conduct electricity. It is just the opposite of our metal. For example, we have here carbon, sulfur, oxygen, nitrogen, etc. So moving on, let us study the physical properties. So let's go first for our metals. The physical properties of metals. Now number one, what is the first thing? Metals are malleable. malleable. Metals are malleable. The word here, this means that our metals, all of these metals, we have copper, iron, aluminium, gold, silver, we have chromium also, sodium also, potassium also, nickel also, cobalt also. We have so many metals. Now these metals can be beaten into thin sheets. They can be beaten into thin sheets with a hammer without breaking them. And our gold and silver metals are some of the base metalloid metals. Now, aluminium and copper metals are also highly malleable metals. All of these metals that we have taken examples just now, they can be beaten with a hammer to form very thin sheets known as foils. Foils, foils. For example, we have here our silver metal. Our silver metal can be hammered into thin silver foils because of its high malleability. Silver and gold, they have very high malleability. The silver foils are used for decorating sweets. Similarly, we have our aluminium foil also. Aluminium foil, which is also quite malleable and can be converted into thin sheets known as aluminium foil. It is also known as aluminium foils. And we have our aluminium foils, we have where we get our packaged food items like biscuits, chocolates, medicines, even cigarettes, and many more things, even milk. So all of these are examples of our metals which show the physical property known as malleability, means they can be beaten into thin sheets. Thus our malleability is an important characteristic property of metals. Now the second one, metals are ductile. ductile, ductile. Now here metals are ductile. It means that the metals can be drawn or they can be stretched into thin wires. They can be stretched into thin wires. All the metals, however, they are not equally ductile. Some are more ductile than the others. Some are lesser ductile, where some are very highly ductile. Gold and silver, another again on our gold and silver, having high malleability also. Gold and silver are amongst the base ductile metals. That means gold and silver, they can be easily stretched or drawn into thin wires. Now, therefore, even copper and aluminum metals are also very ductile, and they can be drawn into thin wires, which are used for electrical wiring. The wires that we use, they are generally made up of copper and aluminum, since they are cheaper than gold and silver. Thus, ductility is also another important characteristic property of metals. So we see here that from these two, from the property of malleability and ductility, we see that metals are malleable and ductile. So it is due to these properties of malleability and ductility that metals can be given different shapes to make different types of articles. Now let's move on to our third one. The third property of metals. Metals are, number 3, good conductors. Good conductors of heat and electricity. Now this is also an important property of our metals. Now, how do we say that they are good conductors of heat and electricity? It's because this means that the metals allow heat and electricity to pass through them easily. Metals are good conductors of electricity. Now, silver metal. Our silver metal again. Silver metal is the best conductor, the base conductor of heat. It is the base conductor. It is the base conductor of heat, and it has the highest thermal conductivity. The copper and aluminum metals are also very good conductors of, like we have copper, Cu, copper and aluminum. Aluminum metals are also very good conductors of electricity. So here the cooking utensils, the utensils that we use to cook our foods, and water boilers, even our water boilers also, they are usually made up of copper or aluminum because they are very good conductors of heat. The porous conductor of heat amongst metals. The porous means they conduct, of course they conduct heat and electricity, but very poorly. The porous conductor of heat and electricity is our lead. Lead metal is the only metal that is the porous conductor of heat and electricity. Even our mercury, mercury metal also is a porous conductor of heat. Now metals, as we know, they are good conductors of electricity. These metals also offer very little resistance to the flow of electric current, and hence they show high electrical conductivity. Now we know that since silver metal is the base conductor of electricity, they will provide very high electrical conductivity. Copper metal is also another base conductor of electricity, followed by we have gold, copper, COPP, copper. We even have gold, aluminum, and tungsten. Here, the electric wires, generally the ones that we use in our domestic wiring, are made up of copper and aluminum metals because they are very good conductors of electricity. And metals like iron and mercury also offer comparatively greater resistance to the flow of current, so that they have lower electrical conductivity. Now, so let's move on to the fourth point. Metals are lustrous, T-R-O-U-S, lustrous or shiny. Shiny. And can be polished, Now here, for example, we have gold, silver, and copper. They are our gold, silver, and copper. They are all very shiny metals, and they can be easily polished. The property of a metal of having shiny surface is called metallic luster. Metallic luster. The property of a metal having a shiny surface is called a metallic luster, and the shiny appearance of metals makes them useful in making jewelry and other decoration, and we use them for other decoration pieces, so that pieces. For example, gold and silver our gold and silver, they are used for making jewelries because they are very bright and shiny. And then the shiny surface of metals also make them good reflectors of light. Silver metal is also an excellent reflector of light. Now let's move on to the fifth point. Metals are generally hard. Metals are generally hard. Except, we have one exception here, except for sodium. Sodium and potassium metal, and potassium metal, they are soft. They are soft metals, but most of the metals except from our sodium and potassium, they are very hard. But all metals, also remember, they are not equally hard. The hardness will vary from a metal to a metal. Hardness vary from a metal to a metal, and most of the metals, like we have our iron, copper, aluminium, etc., they are very hard, very hard. They cannot be cut with a knife, and but there are some exceptions where our sodium and potassium, since they are soft metals, they can be easily cut with a knife. Now, the sixth physical property, the metals are usually strong. That means they have high tensile strength. High tensile strength. Now here, this means that a metal can hold large weights without breaking. Let me write it down. Hold large weights without breaking. Metal can hold large weights without breaking. For example, iron metal in the form of steel. When our iron metal in the form of steel. Iron metal in STEL, steel, is a very strong metal having a high tensile strength. Due to this, the iron metal is used for construction of bridges. It is used for construction of bridges, for buildings, railway lines also. Railway lines. We have railway lines, even our critters, machines, and even vehicle parts and chains, etc. So since our iron in the form of steel, it is a very strong metal, therefore it is used for building bridges, building houses, railway lines, critters, machines, vehicles, and chains. Though most of the metals are strong, but some of the metals are not very strong. For example, again, we have our sodium and potassium. Although they are metals, they are soft metals, and so are sodium and potassium. Sodium and potassium, they have a very low tensile strength. Now, moving on to the seventh property. Metals are solid. Solid at room temperature. Metals are solid at room temperature. Now this means except for mercury. Again here, except mercury. Except for our mercury here, which is a liquid metal, all the metals like we have our iron, copper, aluminium, silver, gold, etc., they are all solids at room temperature. The only metal which is liquid at room temperature is our mercury. The remaining, all the rest of the metals, they are solid at room temperature. Now, the eighth point, the eighth physical property is they generally have high melting and boiling points. Now this means that most of our metals, they melt or vaporize at very high temperatures. For example, our iron metal have a very high melting point of our iron metal. The melting point is almost equals to 1535 degrees centigrade. Now this means that the solid iron melts and turns into its liquid form, or molten iron on heating to a temperature as high as 1535 degrees centigrade. Copper metal also have a very high melting point. Our copper, they also have a very high melting point, that is 1083 degrees centigrade. There are, however, some exceptions, like again for our sodium and potassium metals, they have very low sodium. Again, we have our sodium and potassium. They have very low melting points. They have very low of less than 100 degrees centigrade. So this is the difference in the melting and the boiling point of some metals and non-metals. So here, now moving on to the ninth property of a metal and non-metal. Number 9. Metals are sonorous. S-O-N-O-R-O-U-S. Metals are sonorous this means that metals make a ringing sound when we strike them. A ringing sound when we strike them. So it is due to the property of sonorous of metals. It is due to this property of metals that they are used for making bells, different type of musical instruments like cymbals, and also wires for string instruments like such as violin, guitar, sitar, and many more other different types of instruments. Now our number 11. Metals usually have a silver or gray color. Metals usually have a silver or gray color. Here, except for copper and gold. Copper has a reddish brown color. Our copper has a reddish brown color, and then our gold has a yellow color. Almost all the metals, they have a silver or a gray color. Thus, the metals, from looking at all these 10 physical properties, we see here that metals are widely used in our daily life for a number of purposes. The cooking utensils, electric fans, the sewing machines, the cars, buses, trucks, trains, ships, and airplanes are all made up of metals and mixtures of metals, which are also known as alloys. So in fact, this list of articles made of metals which we use in our daily life is very unending, and thus we can see from here that metals are of great importance for us. Now secondly, let's move on to the physical property of our non-metals. Now we know that a non-metal is an element that is neither ductile nor is it malleable, and it does not conduct electricity. Also, it is just the opposite of a metal. For example, we have our carbon, nitrogen. We have oxygen also. We have oxygen, sulfur, we have fluorine, chlorine, bromine, iodine, also helium, also neon, argon, krypton, xenon. All of these are non-metals. Here our diamond and graphite are also non-metals. Our diamond, D-I-A-M-O-N-D, diamond, and graphite, G-R-A-B-H-I-T. They are also non-metals, and they are the allotropes, A-L-O-T-R-O-P-S, allotropes of carbon. They are the allotropes of carbon, and all non-metals are solids or gases except for bromine, which is liquid at room temperature. So let's check out some of the physical properties of our non-metals. The first one, non-metals, they are non-malleable. Just the opposite of metals. That means non-metals, they cannot be beaten into thin sheets with a hammer. Non-metals, they break into small pieces when hammered. They cannot be beaten into thin sheets, but the moment you hit a non-metal, they will break up into numerous small pieces. For example, sulfur and phosphorus are solid non-metals. We have our sulfur and phosphorus. Sulfur and phosphorus are non-metals. They are solid, but they are not malleable, and they cannot be beaten into thin sheets with a hammer. Thus, we cannot get thin sheets from non-metals because they are non-malleable. Brittleness, or metals are brittle. Brittle here, the word here, brittle. Brittle. Brittle means they can break easily. Brittleness is a characteristic property of a solid non-metal because they cannot be beaten into thin sheets, but instead they get hammered into many smaller pieces. The second one, metals are not ductile. Again, the opposite of our metals. This means that our non-metals, which are like our carbon, nitrogen, oxygen, helium, neon, all of these, they cannot be beaten in the form of wires. They are easily snapped on thread. The moment we stretch non-metal, they easily snap off or they break off easily. For example, against our sulfur and phosphorus, they are non-metals, they are not ductile. When we stretch sulfur and phosphorus metals, they break into pieces and they do not form wires. Thus, we cannot get wires from non-metals. Thus, from our number 1 and number 2, we see here that non-metals are neither malleable nor non-metals are ductile. But we say that non-metals are brittle. Now the third one, they are bad conductors, very bad conductors of heat and electricity. Bad conductors of heat and electricity. We know that our metals, they are good conductors of heat and electricity, but whereas our metals, they are bad conductors of heat and electricity, which means that non-metals do not allow heat and electricity to pass through them. For example, sulfur and phosphorus are the solid non-metals. They do not conduct heat or they do not conduct electricity. Many of the non-metals are, in fact, they are insulators. That means they do not conduct electricity. But we have one exception here, diamond. Diamond and graphite, they are the allotropes of carbon, and we know that our diamond and graphite, allotropes of carbon, they are also non-metals, but they are good conductors of heat. Our diamond is a good conductor of heat, and graphite is a non-metal which is a good conductor of electricity. Therefore, our graphite being a good conductor of electricity, graphite is used for making the electrodes in tri-cells. Number 4, metals are not lustrous. Metals are not, they are dull in appearance. Now metals do not have a shiny surface, or they have a very dull appearance. They do not show any luster. So they are known as non-metals. We say that we say that non-metals are not lustrous. Number 4, they are generally number 5, they are generally soft. Non-metals are generally soft, except for diamond. Except for diamond, most of the solid non-metals, they are quite soft. They can be easily cut. We can easily cut a non-metal with a knife. For example, again, we have our sulfur and phosphorus, even sodium also. They are the non-metals and they can be easily cut with a knife. Diamond, and our diamond here is the hardest natural substance known till date. Now number 6, metals are not strong. That means they have very low tensile strength. Since they are not strong. This means that metals, they cannot hold large weight. For example, graphite is a non-metal which is not strong. It has a very low tensile strength, and when a weight is placed over a graphite sheet, it will easily break off. So we say that metals are not strong as they have very low tensile strength. Now here, non-metals, number 7, non-metals, they can be solid. They may be solid also, they may be liquid also, or they may be gases, at room temperature. We know that all metals are solid at room temperature except for mercury. But here, metals may be solid also, they may be liquid also, or gases at room temperature. Now here, point number 8, non-metals, they have comparatively low melting and boiling points. Except for graphite here, which is a non-metal, except graphite, which is a non-metal, it has a very high high melting point. This means that our non-metals, they can melt and vaporize at comparatively lower temperatures. And our only known non-metal is the only non-metal that has a very high melting point, almost approximately equals to 3700 degrees centigrade, whereas the remaining of the non-metals, they have very low melting point, generally around 100 to 200 degrees centigrade. Now number 9, the metals, they have low density, they are not sonorous. The non-metals are not sonorous. That means they do not produce any sound. And our non-metals, number 10, non-metals have many different colors. Non-metals have many different colors. For example, our sulfur, they have sulfur is yellow in color. Our phosphorus is white, or it can be red. Graphite is black. Our chlorine is yellowish green, bromine is red brown, and hydrogen and oxygen, they are colorless. So our non-metals have many different colors, whereas our metals, we know that our metals, they usually have only shiny or a gray color, except for copper and coal. Copper has a reddish brown color, whereas our gold has a yellow color. So though non-metals, they are very smaller in number as compared to our metals, though our non-metals are smaller in number as compared to our metals, but they play a very important role in our daily life. In fact, life would not have been possible without the presence of non-metals on this earth. For example, carbon, the most important property, carbon, we have studied that in the previous chapter. Carbon compounds like proteins, fats, carbohydrates, vitamins, enzymes are all essential for our growth and development of living beings. So, and another non-metal, even oxygen, is equally important for the existence of living organisms, because we need oxygen to breathe in. This is because the presence of oxygen in air is essential for breathing to maintain life. If there is no oxygen, life will not be able to exist on the earth. So it is also necessary, and even our oxygen is also necessary for combustion, that is burning of fuels which provide energy for various purposes. So we see here that metals and non-metals, they are both essential for the survival on earth, because without the presence of any one of the metals and non-metals, life would not be possible on earth. So these are some of the physical and the chemical properties of our metals and non-metals. So in the next video I'll be explaining the chemical properties of our metals and non-metals, how metals and non-metals react, or how they react with air, how they react with water, etc. So this will be the video explanation on the physical properties of metals and non-metals. Thank you.